Good day. For those of you who do not know us, we are the instructional staff for ECE 150, Professors Hiran Patel and Werner Dietl, and Douglas Harder. In this topic, we will start by reviewing assertions. We will then introduce you to various exception classes. We will see that instances of these exception classes may actually be thrown, and that by default, a thrown exception will also immediately terminate the execution of the program, just like a failed assertion. However, we will then learn how we can catch an exception in a try-catch statement and deal with them accordingly and allow the program to continue executing once you have dealt with the problem. Now, to this point, we have discussed and used assertions. Assertions are powerful and useful because they terminate the program immediately and indicate the condition that failed. Now, one other interesting point is that assertions can be turned off, meaning that you can keep all assertions turned on during code development, so that if during code development an error is made in programming, you immediately know about it. However, you can turn all of the assertions off when you build your releases that will then be delivered either to your client or your customers. Turning off all assertions is as easy as including define not debug or ndebug at the very top of your source file. At this point, if ndebug is defined, the condition is not even checked. This turns off all assertions and is completely equivalent to erasing all assertions prior to compilation. The issue with assertions, however, is that in release code, they would have the nasty habit of terminating the user's program. This is not going to make for very happy clients or users. Nurse, turn on the artificial lung. Yes, doctor. Nurse, turn the artificial lung back on. Doctor, it says something about disk full. We need an approach similar to assertions that can be more safely used in deployed code. That is, we can signal that a problem has occurred, but it also allows us to deal with it. So first, we will present how we can signal that there is a problem. We are going to throw an exception. Next, we will see how we can deal with such a problem seamlessly, and in that case, we will be catching these exceptions. Now, when something unexpected happens in your program, you can throw an exception. There are numerous classes considered to be exceptions, all defined in the standard except library. Now, each of these is there specifically to indicate a type of error, and you can also define your own class exceptions. So, for example, logical errors tend to indicate problems in coding, while runtime errors indicate problems that may not have been able to have been determined at coding time. So a logical error may be something such as a domain error. The argument is wrong, or simply an argument is invalid, or the length of an array is the wrong size. Runtime errors, however, tend to be something that you may not be able to determine that there was a problem initially, such as overflow or underflow in a calculation, or perhaps that the output is not in the actual expected range. However, you don't have to understand each of these. So just like a return value, we can throw an instance of one of these classes. So here we have an integer square root function. If the argument is less than 0, we will then throw an exception. And notice that we can put more information into this exception. In fact, we can put as much information as we want because there really isn't any problem yet. We simply have to craft a string that contains sufficient information to let the user know what's wrong. Here's the full program. So if n is greater than or equal to 0, we go into the second half where we calculate exactly the integer square root of n using a for loop, a few bit shifts, bitwise ands, and bitwise ors, as well as one addition and one subtraction. Now, if you call this function with an invalid argument, like an assertion, if you do nothing else, the program will terminate. So here we call the integer square root with -10. We try to run this program, and the output is terminate, called after throwing instance of domain error. What's wrong? Cannot compute the square root of -10. If you wanted, you could include even more information in your exceptions. In fact, you can include a lot of information in your exceptions if you design your own exception class. And then, of course, because we did nothing else, the program is aborted and a core was dumped. Now, if all you do is throw exceptions, exceptions are no different than assertions that fail. They terminate the program. However, the difference is that we can catch an exception. So if an exceptional circumstance is occurring, we can throw an exception, but then we can catch that exception and run code specifically designed or authored to deal with that specific issue. That is, we can fix the problem and continue executing the program, having dealt with the problem appropriately. Now, here's an example of code that can catch exceptions. There's a lot of overhead for catching exceptions, so the compiler does not do this automatically. You actually have to say, hey, try running this code, and if you catch an exception, or if an exception is thrown while this code is executing, then we can deal with it. However, if there are no exceptions thrown, then that code will run as per normal. So even if there was no try block wrapped around this code, it would run normally and it would print the integer square roots of those 3 values. If nothing special occurs, if no exceptions are thrown while those 3 statements are executed, then we just carry on down to the end and carry on executing the program. So please try again. However, if an exception is thrown, we may be able to catch it and do something with that exception. Now, let's try executing these 3 statements inside the try block. Now, when the first statement is executed, there are no problems because the integer square root is calculated and returned and thus printed to the screen. So that's the integer square root of the given argument. When we execute the next statement, however, the argument is negative. Consequently, the function will throw an exception. Now, if this exception was thrown outside of a try block, then automatically it would terminate the program. However, because it is inside the try block, we can try to catch that exception. So if an exception is thrown, we now start looking at this catch block. Now, following the keyword catch, you will see that it looks eerily similar to a parameter of a function. There's a type, and E is the catch parameter, and it is, in the exception, is passed or thrown by reference. E also must be of an instance of the standard domain error class. So if a domain error is thrown inside the try block, anywhere inside the try block, then we start executing this code here, and whatever exception was thrown is assigned to the catch parameter E. All right, in this case, all we're doing is printing out a string that explains to the user what has gone on. So in this case, we're printing some information to the string, and then we call a member function of the exception class. What is a member function that returns the string that was passed to the constructor of the exception class? So we're just printing to the screen what was in that exception class. What's really nice now is there are no more ill effects from that exception being thrown. The program just continues to execute as per normal. So please try again, and the program finishes. Now, just in case you don't know what you're catching, you can still do that. So here again, we execute this first statement and we get the output printed. We execute the second statement, output is printed. We execute the third statement, oh, an exception is thrown. In this case, we jump to this catch block where rather than having a catch parameter, we just have 3 dots, ellipsis. And this is interpreted by the compiler as saying, if any exception is thrown, jump here. Notice that there is no exception or catch parameter, so we don't have any information about what was thrown. All we know is something bad happened. So in this case, all we can deal with is the fact that an exception occurred. And once the catch block is finished executing, the program just continues executing as per normal. And so once again, at this point on the call stack, there is no more evidence that there was any problem whatsoever. Please try again. Now, just like a conditional statement, however, if the type of the catch parameter does not match what is thrown, then that catch statement does not execute. Here we see a catch block where the catch parameter is of type standard range error. You may remember that the integer square root function is throwing a domain error exception. So this catch block will not catch that exception thrown. So if we execute this program, the exception is thrown, it is not caught, and consequently it will terminate the program as per normal. A try-catch statement, just like a conditional statement, can have cascading catch blocks. So if while executing the try block an exception is thrown, the first catch block that matches what is thrown is the one that is executed. So here the first catch block is attempting to catch a range error exception. Well, in this case, a range error was not thrown, so we go on to the next catch block. Yes, a domain error was thrown, so in this case, we will execute the corresponding catch block. So this is just going to print to the screen that a domain error was caught. Once this code is executed, we are finished with the try catch statement, and we continue executing at the bottom and please try again. So here the output would just be the two numbers. The string domain error was caught is printed to the screen, and then once again, please try again. And again, at the bottom, there's no further record that there was any problem whatsoever. Now, it's important to note that it will execute only the first catch block that matches. So in this case, the ellipsis catches all exceptions that are thrown, and so automatically, once the domain error is thrown, because the ellipsis is the first catch statement, it is the one that will be executed. So even though there is a catch block specifically for domain errors, this particular domain exception will be thrown and caught by this first block. So now we will only be able to indicate to the screen that an error was caught. So we do have to be careful about the order. You may be wondering, do we use assertions or do we throw exceptions? Well, in this course and in your career, you will continue to use both. Assertions will be used in your code to ensure that the code is executing as expected. That is, you're going to be using assertions to check that conditions you expect to be true are actually true. And if those conditions are false, that means someone made a mistake somewhere in the source code during development. Exceptions will be thrown if there are potential errors during the execution of the code, and these exceptional circumstances must be dealt with. For example, invalid arguments or a result that was invalid. For example, the failure to deal with exceptions at runtime have led to numerous problems. The first launch of the Ariane 5 rocket resulted in the destruction of the rocket about a minute after launch due to an uncaught exception where an overflow occurred. The Clementine satellite simply allowed division by zeros to occur without catching those exceptions, and this caused the system to reboot every time such an error occurred. This was fine the first 1,000 times it happened, but one time this reboot happened at a critical moment when the satellite should have been responding to a thruster that was being fired. Now, one question you may be wondering, why not use exceptions everywhere? Well, exceptions are expensive and require significant infrastructure. Suppose you have a try-catch statement. You call a function from the try block. That function calls another function, which calls another function, which calls another, which calls another, which finally throws an exception you are catching. At this point, each of the functions that have been called have parameters and local variables on the call stack, and all of this must be undone without executing any more statements within any of those functions. We have to jump all the way back to the appropriate catch block and start executing that next statement in that catch block. That's a lot of overhead. That is fine if you have programs that are running on general purpose desktop or laptop computers or even your cell phones. It's not so great if you're dealing with embedded or real-time systems. So try catch statements are great for general purpose computing. When there are pressures for time or space, on the other hand, they may be less than optimal. Now, here's a nice example of using a try-catch statement. Your program may set up a network connection with a remote system that you need to communicate with. You're then executing code that expects that network connection to be up. And indeed, there may be a significant amount of code that is being executed. You may be sending queries across the network, expecting information back, and having continuous communications with that remote system. The issue is you do not want every single function that is communicating on that network to have to deal with network failures. If this is true, every time you try to communicate on the network, you'd have to have code that checks if the network is up, and if the network is down, try to deal with it. You may have 20 or 30 places where you'd have to insert code where you are trying to reestablish a network connection if a failure occurs. Instead, what you can do is as follows. The code is executed inside a try block, and then the first function to detect a network failure can simply throw an exception back that is caught at the top level, and the corresponding catch block can either try to reestablish a network connection, or if that fails, signal that a network connection has failed and could not be corrected. So what happens then? Well, that depends. If this is an interactive user application, then the user may simply be prompted to ask, what do you want done now? Can you give us a different IP address, or is there something else you want done? Alternatively, the failure may simply be entered into an error log, and subsequent execution of code may inspect this error log and see, oh, the previous code did not run to completion because a network connection failure occurred. All right, following this topic, you have now been exposed to the various exception classes. If an exception is thrown and not caught, then the program terminates. You also know that each exception class has a what member function that returns a string that was passed to the constructor of that exception object. You know that thrown exceptions inside try blocks can be caught with the corresponding catch blocks. And so, like cascading conditionals, you can have cascading catch blocks, and the first that matches is the one that is executed. The catch with ellipses is similar to the condition if true. Also, you now know that once the first matching catch block is finished executing, the program keeps on executing as per normal. No additional evidence remains that something has occurred unless, of course, the code in the catch block recorded that an exception occurred.
Here are the references, the colophon, and a disclaimer. Cheers!